Yeah, last one left was D. Okay. Okay, fine. Okay, capacity is at E, complete free flow at A. If you are traveling on rural freeways, then you travel at expected speed up to level of service B. For urban freeways, it is C. Maximum continuous flow as D, and Q formation is very obvious as at F. Okay, well done. Let us move on to what we were doing earlier. Ended the discussion at service flow rate, which is the maximum flow rate you can have at a particular level of service. So when the highway on when the flow rate on the highway exceeds the service flow rate of a level of service, that level of service is no longer applicable to the highway. So if a highway has a flow rate more than the service flow rate of A, that means level of service A cannot be applied to the highway, and so on and so forth. Okay, and you go up to level of service E. Now, I told you yesterday there are three types of uninterrupted flow facilities: basic freeways, multi-lane highways, and rural two-lane highways. Out of these two, we will discuss two of them, two together, which are freeways and multi-lane highways. Why we are discussing them together? Because their procedure for calculating level of service is the same. Okay, or you can say similar, not the same, similar. Okay, so we can discuss them together, and this is what we will do in these slides. In the next chapter, in the next topic, once we finish them, we will move on to the discussion of two-lane highways. Okay, so two-lane highways are not discussed in these slides. Whatever we're discussing is for freeways and multi-lane highways. Okay, so first of all, we need to define what do we mean by freeways and multi-lane highways. So freeways, the main point defining a freeway is purely uninterrupted flow facility, a facility which does not have any interruptions. Okay, so if you want to enter a freeway or exit a freeway, it will be done through a ramp, and which brings another important point to consideration here, that ramps are not considered as interruptions. Ramps by default are not considered as interruptions until unless you make it into something special. Why? Why is that? Why don't we consider a ramp as an interruption? Because for a ramp, the flow on the freeway is not supposed to stop. Okay, the ramp has its own lane, people go enter and exit from there. The flow on the freeway is not supposed to stop or get distracted because of the ramp. Okay, so ramps are not considered as interruptions. Okay, what are interruptions? The main form of interruption is an intersection. So freeways, since they are pure uninterrupted flow facilities, they don't have any at-grade intersections, zero. Okay, another form of interruption can be access to driveways, garages, parking lots, or even to on-street parking. All of them are considered as interruptions. Okay, somebody is coming out of the parking lot, you have to stop for that. Okay, freeways do not have any at-grade intersections. They don't have any access to driveways, any access to parking lots, garages, or any roadside parkings. Okay, this is mandatory for freeways. Okay, another important point for the freeways always have medians. It's not written here, but when I define multi-lane highways, you will get this point as well. But you can note it down that freeways have to have medians. Okay, and freeways have 4 lanes or more. Freeways have 4 lanes or more. Okay, so a highway which fulfills all these conditions can be referred to as freeways. What are the conditions? No interruptions. Okay, no interruptions including no at-grade intersections, no access to driveways, no on-street parking. Okay, they have median, they have 4 lanes or more. Okay, and all the entries and exits are through ramps. Then we come to multi-lane highways. Multi-lane highways have interruptions, but the spacing between the interruption is at least 2 miles or more than 2 miles. Okay, whatever type of interruption, maybe between an intersection and on-street parking, maybe between an intersection and another intersection, maybe intersection or another driveway or garage. any type of interruption, the spacing between them is more than 2 miles. Okay, then you can call it that highway, and the highway has again 4 lanes or more. Then you can call that highway the multi-lane highway. Okay, now median for a multi-lane highway is not necessary. So a multi-lane highway which has a median is known as divided. The multi-lane highway which doesn't have a median is called as undivided. Okay, so multi-lane highways can be divided or undivided depending upon whether you are providing a median or not. Okay, but both possibilities are there for multi-lane highways. For freeways and multi-lane highways, the main thing which defines their capacity is free flow speed. If you remember, I showed you a table on Sunday where the capacities of multi-lane highways and freeways were given, and they were changing with respect to their free flow speed. Okay. Now my question to you is, what is the relationship between free flow speed and capacity? Is it directly proportional or inversely proportional? The relationship between capacity and free flow speed, is it directly proportional or inversely proportional? What do you say? Inversely proportional? Everyone is saying inversely. You already said inversely, right? Raneem, can you give me, yeah, directly. It is directly proportional. Yes, it is directly proportional. For the people who said inversely proportional, clarification. Free flow speed is a speed which you will achieve when the flow is very low. Okay, so your speed will depend upon the design of the road. Okay, better design, higher free flow speed. Yeah. Capacity is again goes with the same logic. Capacity is how many vehicles the road can carry. Okay, so better design will have more capacity, more vehicles carry. It will carry more vehicles. So capacity increases when free flow speed also increases, because both are dependent upon design of the road. Another clarification which somebody asked me in the previous section. So another clarification is like I told you, you measure the free flow speed when the flow is close to zero. Okay, so free flow speed doesn't mean that you will the speed at capacity. No. Okay, free flow speed cannot be reached at capacity. Okay, so when the flow of the road, the actual flow of the road, I'm not talking about capacity. The capacity is fixed, whatever you have designed the road for, but the actual flow on the road can be very low or can be very high up to capacity. So when the flow is very low, the speed which you will achieve is free flow speed. When the flow is very high, it will be equal to capacity and the speed will be very low than free flow speed. Okay, so free flow speed and capacity both are dependent upon the design of the road, but they will be achieved in two different conditions, of the flow. Okay, so when the actual flow is very low, the speed will be free flow speed. When the actual flow is very high, the speed will be less than free flow speed, but the flow may be equal to capacity. Okay, but both are dependent upon the design of the road and both quantities are fixed and they are directly proportional. They are directly proportional. The roads which are designed better will carry more vehicles if required, and in low flow conditions their free flow speed will also be higher. Okay, so I hope this clarifies it, but I am happy to see that many of you gave me the correct answer. Okay, directly proportional. They are directly proportional. Okay, so free flow speed, you need the free flow speed to calculate capacity and level of service for freeways and multi-lane highways. Now, for calculation of free flow speed, we are going to use, you can measure the free flow speed on the road, right? Like you have done for your term project. In your term project, in the second submission, I asked you to calculate the speed on the roads and calculate the mean, and that mean becomes your free flow speed. Okay. So free flow speed on most of the roads, the minimum, the minimum flow up to which you can maintain free flow speed is 1000 vehicles per hour per lane. On most of the freeways and muddy highways, drivers tend to maintain a speed close to free flow speed when the flow reaches 1000 vehicles per hour per lane. Okay, so when the flow goes beyond 1000 vehicles per hour per lane, then the speed of the drivers may or may not be equal to free flow speed. Okay, but up to 1000 vehicles per hour per lane, you are sure that for all muddy highways and freeways, the free flow speed is attained by the drivers. Okay. Now the calculation which we are looking to see, which we are going to see for capacity and level of service depends upon the graph or the curve between speed and flow. Okay, so in the earlier manuals, they used to give us the graph in the manual itself, and then they said that use the graphs and find out the capacity and level of service and so on and so forth. But in the new manual, they have given us the equations. And they are saying in the old manual, they said you can use a graph with approximation. Okay, so even if your values, your own values are not exactly matching the value of the graph, you can still use it by approximating the values. Okay, rounding off. But in the new manual, they are saying no. Either you have the values which are exactly given in the manual, then use the graph which are given. Or if your values are not exactly matching, then we are giving you the equations. Okay, so they have given the equation for the graph between speed and flow. They have given some graphs as well. Some curves are already given, and you can use them if the values of your highway are exactly matching the value of the graph. Otherwise, you can develop your own graph using the equations given in the manual. Okay, I will show you everything in the coming slides today, inshallah. Okay, these graphs are plotted assuming the flow is happening under base conditions. If you remember the table of capacities which I showed you on Sunday, on top of that table, it was also mentioned that capacities under ideal conditions. So ideal conditions, base conditions are almost the same. Okay, so what do we mean by that? Base conditions, you can see the 2 points written at the bottom of the slide. There are two base conditions, and whenever you are using the equation on the graph, these two base conditions must be met. Okay, the first base condition is that no heavy vehicles on the highway. So all vehicles are what? They are passenger cars. All vehicles are passenger cars. First base condition, ideal condition. The second one is all drivers are, the driver population is dominated by regular and familiar users of the facility. Facility meaning the highway. So they are saying most of the drivers, almost all the drivers are regular and familiar with this highway. They are regular users of the highway and they are familiar with the highway. Okay. Now, what is the reason of setting up these two base conditions? If you fulfill these two base conditions, then you can achieve maximum possible capacity. Okay, why? For example, if there are heavy vehicles on the road, heavy vehicles, they take up more space and they move slowly. So with the heavy vehicles, number of vehicles passing the road will be less because the speed of the road will be low, and less vehicles are taking up more space, so the capacity will be lower. So having no heavy vehicles gives you more capacity. Okay, more space on the road, more speed, and so on. And same thing with the regular and familiar drivers as well. If you are unfamiliar with the highway, if you are an irregular user of the highway, then you will tend to go slowly. You will be more cautious, and you may be making more maneuvers, more lane changes, more directional changes, because you are not sure when to do what. Okay, so unfamiliar drivers, irregular drivers tend to reduce the speed and they tend to increase the possibility of accidents. Okay, so if you have regular or familiar drivers, they will move faster and they will make less maneuvers. You will be safer and faster, so the flow will be higher. Okay, so these two base conditions, when they are met, they will result in having the maximum possible capacity. Now we have discussed the main point, which I showed you today earlier as well, about each level of service. Okay, so you get these main points, but there is some more explanation given for each level of service now in these slides. So level of service A means complete free flow. You are not affected by other drivers. The flow is so low that you have lots of spacing between you and the other drivers. If you want to change your lane or change your direction, it is very easy for you because you don't have to worry about the other drivers. Okay. In this condition, if you have some blockage in a lane, in a particular lane, the flow will not be stopped. The level of service may deteriorate because of that, but the flow will remain continuous. Okay, because there are lots of gaps available. Okay, so for example, you are driving in level of service A, you see one lane is blocked because of maintenance activity, or one driver has stopped in that lane because of an accident or because his car has broken down. So you can easily move to the other lane because there's so much gap available there. Okay, and you can see the last point on the slide is the average spacing between the vehicles in level of service A, and this is mentioned in all the other levels of service as well. So you can see they are decreasing, the gaps are decreasing. Then you have level of service B. Now I have mentioned earlier that drivers tend to maintain free flow speed up to a certain level of flow rate. Okay, so level of service B also comes under the same region, under the same condition. Okay, so you are still maintaining a speed which is close to your free flow speed. So level of service B is still considered more or less free flow state. Okay, but now the gap between you and the other drivers has reduced compared to level of service A. So now you are becoming more careful and vigilant. Driving is still easy, maneuverability is still easy. You want to change your lane or direction, you can easily do that, but you have to practice now more caution and vigilance because that gap has reduced. Still, it is enough to do anything. Okay, it is enough to change the lane and change direction, but you need to be more careful because it has reduced now. Okay, so if you make a mistake, there are more chances that you will block other drivers or cause an accident. Okay, but still the gaps are so frequent and they are so large that you can still afford to have some disruption and keep the flow moving. So still in level of service B, disruptions will not cause the flow to be stopped. Okay, so these disruptions may cause the level of service to deteriorate. So if a lane is blocked in level of service A, because of that blockage, the level of service may deteriorate from A to B to C. Okay, but the flow will still remain continuous. Same thing with level of service B as well, and level of service C is more or less same. Okay, but the only additional factor here is maneuverability is restricted. Okay, so the gaps with every level of service, the gaps are decreasing. So obviously when the gaps are decreasing, I'm talking about the gap in traffic flow, the gap between the vehicles. So if the gaps are decreasing, your carefulness should increase or would increase. Okay, because the other vehicles are close. But in level of service C, the additional point is maneuverability is now restricted. The gaps are not so frequent and they are not so large. So if you want to change your lane, you may have to wait for the other drivers to give you the chance. Okay, but level of service A and B, it was very easy. You wanted to change and instantly you may be able to change. Okay, with some care, you may be able to change. But level of service C, the gaps are now very infrequent and they are smaller. So you may have to wait for implementing your decision to maneuver to other lane or to change your direction. You may have to wait now. Okay, so you are moving in your lane straight. You can still go at very high speed, which is close to the free flow speed of the road. But you want to change your lane, the other lane may not have a gap for you right now. It may appear after 2 or 3 seconds. Okay, so in that case, you are waiting. Okay, but still you are going at high speed in a straight line. Going in a particular lane doesn't have any problem right now. Okay, then we have level of service D. Okay, so from level of service D onwards, the speed starts to decrease. The speed starts to decrease. Okay, and what should happen with the density? Can someone tell me? When speed decreases, density, what? Increases or decreases? Speed decreases, density increases. Yes, yes, good, great. Okay, so you can see I keep on referring to some relationships and some terms which we have studied in the previous chapters. Okay, and someone was asking me this question in the exam yesterday as well, that why the question is about these terms. We covered them in lecture 4, but we discussed them again in lecture 7. What can I do? Okay, so you have to be you have to keep these things in mind. Okay, I cannot review all the equations and all the values from the previous chapters in each and every chapter. Okay, so I can just give you some questions to refresh your memory, but in the end it's up to you how much you retain. So you are right, well done. Increase in speed means decrease in density and vice versa. So when speed decreases, density is increasing. Now in level of service D, up to in level of service A, B, and C, the speed was very much close to the free flow value. But after level of service C, when you reach in level of service D, it starts to deteriorate rapidly now. In level of service D, the speed starts to deteriorate rapidly. And there's a very small window, or there's a very small difference in flow for level of service D and F. There's not much difference of flow rate between level of service D and F. Okay, so you can quickly go from D to F. Quickly meaning in terms of flow. You have a very small increment in flow, and you directly jump to level of service F. It can happen. Okay, so in D now, speed is decreasing, the gap is very low. Okay, and now your maneuverability is now more restricted. Okay, now you don't find gaps so often. So you have to wait for other drivers to you have to wait for the gap to come. Okay, in level of service D, the gaps will not appear until you wait for them. Okay, so or if you know most of the time, obviously you can be lucky that you thought about lane changing and someone was slower in the other lane. It can happen, but most of the times the gap is not there. So you have to wait and be careful. The spacing between you and the other cars is less, and the breakdown can happen very easily, like I said, with a small increase in flow because there's less difference between D and F. Okay, and in this case, obviously, since the gaps are not there so frequently, if you have a minor disruption, it can cause a blockage in the flow. Okay, because if a lane is blocked, I don't find gap in the other lane, what would I do? I will stop. Okay, until I find the gap, I will stop. So a minor disruption level of service D can block the flow. And then you have level of service E, which means capacity. Capacity means fully saturated flow conditions. Okay, and in those conditions, then the gaps are not there. This is what we mean by fully saturated, right? Any usable gap is not there. The gap which you can use to enter the other lane or change your direction is not there. Okay, now it's not there at all. Not there at all. In level of service D, it was infrequent and smaller, but in level of service C, it's not there at all. Okay, so if you have a disruption in a lane, it will definitely cause the flow to be disturbed. Okay, even if you have a small shock wave or perturbation, okay, like a small hindrance in the flow, it can cause a blockage. Okay, so in this level of service, we apply if you have to change my lane, what would we do? We apply the waving technique, right? Waving technique. You go half in the other lane, so the other driver cannot pass you, and then you wave your hand, right? Now let me pass. Okay, and obviously then that poor guy has to let you pass. Okay, so when you have to do it, when you are forced to do it, that condition is level of service C. Okay, if you are just doing it to irritate the other driver, then it's something else. Okay, but you are in one lane and you find that there's a line of drivers going from the other lane and there's no gap between them, and you have to make your way in the other lane and put half of your car there and wave the other. If you have to do it, that is level of service E. Okay, if you are forced to do it to find some gap in the other lane, that level of service E. Okay, now this is a speed flow curve which I was talking about, which is recommended, or which is the major portion of calculating capacity and level of service for multi-highways and freeways, the speed flow curve. So speed on the y-axis, flow on the x-axis. Okay. The speed flow curve, you can see the first part of the curve is a horizontal line. Okay. And that horizontal line is at level of free flow speed. Okay. So like I mentioned earlier, there is a certain range of flow up to which the drivers do not usually, the average speed of the highway does not go below free flow speed. So that is that portion. So your speed is still at free flow level. Okay, although the flow is increasing, but it is not so high that the speed would decrease. Okay, so this is up to level of service C usually. Okay, this point is up to level of service C usually. Okay, then after level of service C, you have D and E, and then you can see the reduction in speed as well. Okay, and the last point on the curve is capacity. Okay, the point up to which the graph is a horizontal line is called breakpoint, BP. BP or breakpoint. The range of flow up till which the speed doesn't reduce, the speed doesn't drop down. Okay, from the free flow value, from the free flow speed value. And the last point of the curve is capacity, which is termed as, or which is denoted by C. Okay. Another important thing which they have done in this manual is they have fixed. It was fixed earlier as well, but now they have mentioned it on the graph as well, that the density which you will achieve when you reach capacity is 45 passenger cars per mile per lane. So any freeway or any multi-lane highway, when it reaches a density of 45 passenger cars per mile per lane, it has reached the flow which is equal to its capacity. Okay, so whenever the density reaches this value, the flow reaches capacity. Okay, simple. And it is fixed for all multi-lane highways, for all freeways, it is fixed. Okay, now the equation of this graph is given at the bottom. Now the first portion of the graph is a horizontal line. For horizontal line, you don't need an equation, right? Okay, so the line is not inclined, so I don't need an equation. It's a single value, right? It's a single value which is equal to free flow speed. So you can see when you reach from 0 up to BP, the break point, the speed is a single value, a constant value. So if VP, what is VP? VP is the actual flow rate on the road. The actual flow rate on the road. Okay. So from 0 to BP, the speed equals free flow speed. Okay. So I need an equation for this curve. Okay. When the flow is more than BP. So when the flow is more than BP, the speed can be calculated using this equation. Okay. So this is the equation for the curve part of the graph. Okay. Now you can see in this equation what I'm using. I'm using free flow speed. I'm using DC. DC stands for density at capacity, which is 45. As I said, it is fixed. Okay, so you can replace DC with 45, no problem. Okay, VP is a flow rate on the road. BP is a breakpoint. Okay, A is a constant. I will come to it in the next slide. Okay, and VP for this equation, for this part of the curve, VP is more than breakpoint and it is up to capacity. Okay, now there was a term which we assign to density when a road reaches capacity. What did we call the density when the road is at capacity? There was a specific term which we gave to it. What did we call? The density is at capacity is called what? No. Jam density is maximum density, and that is in level of service F. When it is jam, I'm talking about density at capacity. So we are moving. Yeah, critical density. Well done, Rani. Well done. Critical density. You call it critical density. Okay, so DC is critical density or density at capacity, means the same thing. Okay, so a couple of important points. Now you can see with FFS, free flow speed, and with capacity, there's a subscript given ADJ. ADJ stands for adjusted. Okay, so once you measure the free flow speed, or you can also calculate the free flow speed. Okay, both things are correct. but either you measure it or calculate it, then you have to apply some adjustment factors. Why? Because of the base conditions. As I mentioned earlier, the values in the graph, the curve, are supposed to be at a time when the highway is fulfilling the base conditions. Okay, so you have to apply some adjustment factors because actual highways do not operate on base conditions, right? Actual highways do not have all familiar drivers and they do not have all passenger cars. So we need to apply some base conditions, some adjustment for the base conditions. So that's why you see FFS adjusted and you see adjusted also written with capacity. Okay, and you can see the units as well. In the graph, units of density, passenger cars per mile per lane, not vehicles per mile per lane. Units of flow rate, passenger cars per hour per lane. Okay, speed is miles per hour. The units don't change, but still there are adjustment factors to be applied to free flow speed as well. Okay, so we have two portions of the speed flow curve. One portion is straight line where speed equals to adjusted free flow speed. The other portion we need an equation to solve it. Okay, and the difference between the two portions is the breakpoint. Now you can see they have drawn a line on the graph and they are saying this line corresponds to density of 45 passenger cars per mile per lane. Okay, how is that? How can I say that this line has a density of 45? Okay, because density equals flow upon speed. Again, going back to lecture number 3, density equals flow upon speed. We know that. Okay, so if you want slope of a line on this graph, you take the inverse of density. You take the inverse of density. Okay, and then you will get the slope for the graph, and you can plot a line from the origin using that slope. Okay, so if you take 45, do the inverse, it will become the slope of this line. Okay, inverse of 45 is the slope of this line. Okay, why? Because density is flow upon speed, and the slope of this graph will be speed upon flow. So you have to do the inverse. Okay, so they have already fixed the value of density, then they took the inverse and they got the slope and they plotted the line using that slope. So that's why they are saying this line corresponds to density of 45, because the inverse of the slope will be 45. Okay, this table shows you the set of equations required to calculate capacity and BP and these things. Okay, so column 2 for freeways, column 3 for muddy highways. Now, so you need the free flow speed. The first thing you need is the free flow speed. Okay, free flow speed can be measured. Okay, when the flow is up to 100,000 vehicles per hour per lane or up to the breakpoint, you can go to the highway in that condition. When the flow is in that range, you can measure the free flow speed, no problem. Okay, and this is what you have done in the second submission of your term project. You have already done it. You have measured the free flow speed of your highways. You have already done it. Okay, the mean speed which you got from the frequency distribution table, that is your free flow speed. Okay, so you will use that value to do the remaining calculations. Okay, the second method of getting the free flow speed is to predict it. Predicted meaning calculated using an equation. Okay, I will show you the equation how to calculate free flow speed, but you don't have to use it in your term project. Okay, everything which we are doing in the class doesn't apply on your term project. The term project is simpler and smaller, and the calculations in the class are more. Okay, because obviously we have to cover the topic. I cannot give everything to be done in the term project. Okay, it will make your life difficult as well as mine. Some of you, many of you have done extra things in the second submission. Okay, so I have noted down in my comments what you have to use in future. Okay, and many of you have done extra things yesterday in the exam as well. And even the data was not given. They were asking me, Doctor, how can I do this? How can I do this? Okay, the thing was not required. That's why the data was not given. And why are you searching for it? Why are you looking for trouble? Okay, don't do it. Okay, so for your term project, coming back to the topic, for your term project, in this topic, I will show you that free flow speed can be measured and free flow speed can be calculated using the speed. In your term project, second method using the equation will not apply. Okay, you have already measured the free flow speed. The mean speed calculated using the frequency distribution table. That's it. That's it. Okay. Just use that. Okay. Because if you go for the equation, then you will need many things more, and then you will keep on asking me. Okay. So don't do it. Okay. So once you measure the free flow speed or predict the free flow speed using the equation, then you will multiply the free flow speed from these methods with combined speed adjustment factors if you are doing it for a freeway. Okay, so speed of the freeway must be adjusted using a combined speed adjustment factor. How to do it, we'll discuss it on Thursday, inshallah. Okay, but we need to apply adjustment on free flow speed of freeway by multiplying it with this factor. Okay, for multi and highways, it will remain as it is, no adjustment. Okay, capacity of freeways, this is the equation. Capacity of multi and highways, this is the equation. Maximum capacity of freeway, 2400. Maximum capacity of multi and highway, 2300. Okay, now what does it mean, maximum? If you calculate the value from the equation for freeway, it comes out to be 2500 passenger cars per hour. This is more than the maximum value. Okay, so you will discard the value from the equation and take 2400. Okay, if you get a value, for example, 2300 for freeways, 2300, then you will keep it as it is because it is less than the maximum. So the value from the equation for multi-highway freeways must be less than or equal to the maximum. If it goes above, you discard the value from the equation, take the maximum value. That's it. Okay. The speed range, free flow speed range for freeway is given, free flow speed range for multi-highway is given. Okay. Once you calculate the capacity from these equations, you again multiply with the capacity adjustment factor for freeways. So free flow speed and capacity for freeways must be multiplied by their respective adjustment factors. So capacity of freeways must be multiplied by combined capacity adjustment factor, CAF. For multi-lane highways, again, no adjustment required for capacity as well. Whatever capacity you calculate will remain as it is. Okay, so all the adjustments are required for freeways only. Okay, then we will see how to calculate combined capacity adjustment factor for freeways on Thursday, inshallah. Then the equation for breakpoint for freeways. This is the equation. Okay, now you can note down one point, that wherever they are using simple free flow speed, they are using FFS, and wherever they are using adjusted free flow speed, they are using with a subscript. Okay, so you don't get confused that which free flow speed I'm talking about. Okay, if the subscript is used, then apply the adjustment, then use it. If it is without the subscript, like here, whatever value you get, you just use that value. Okay, without adjustment. Okay, same thing in this equation as well. The values are required adjusted, so the subscript is there. Okay, so FFS and FFS adjusted are shown completely, different. Okay, don't get confused. So BP for freeways will be calculated in this manner, and BP for multi and highways is fixed. So you don't have to calculate BP for multi and highways 1400, fixed. Okay, then in this equation we need a factor A. Okay, so A is an empirical factor which is given here, 2 for freeways and 1.31 for multi and highways. A is 2 for freeways and 1.31 for multi and highways. And where we are using it in the equation, in this equation. Okay, the equation of this part of the graph. Okay, some of the graphs are already plotted in the manual. Okay, now if the free flow speed of your highway matches exactly, this is a keyword, it matches exactly with the free flow speed given on these graphs, then you can use the graphs and you don't have to use the equation. You may still want to use the equation if you want to know the exact values, because the graph is already plotted, you don't know the scale, so you may be getting approximate values. Okay, so you may still use the equation to find out the exact values for your highway, even if the free flow speed is exactly matching the speed of the graph. Okay, but we have this facility here that if the free flow speed on the graph matches exactly with the free flow speed of your highway, then you can use it. Okay, no approximation required here. You will not say it was 74, it is close to 75, I'll assume 75 and do it. No, 74 means 74. Okay, even 75, 74.5 means 74.5. You cannot make it 75. Okay, so if it is exactly 75, you come to the graph and you can use the graph. Okay, how to use the graph? It is showing the same points which I've showed you earlier. Okay, the last point of each curve is capacity. The point after which the line starts to go down is the break point. Okay, these are the curves for freeways. Okay, and with each curve you see the value of the free flow speed. Okay, and then you see the capacity line. Now with the capacity line, they have plotted some additional diagonal lines here for each level of service. And again, these are plotted using the same approach which we used for the capacity line, that is using density. So for each level of service, the maximum density is fixed. The highway capacity manual gives the maximum density for each level of service, which you can see here. For level of service A, it is 11, for B, it is 18, and so on. Okay, so you take the maximum value, you take the inverse of that value, so it will become the slope of the line, as I mentioned earlier. Okay, density is flow upon speed, and you do the inverse, you will get speed upon flow. So that is the slope of the line. So they took, for example, 11, the density, maximum density at level of service A. They did the inverse of that, so they got the slope of a line, and then they plotted the line according to that slope from the origin. Okay, there is the same thing for 18, 26, and so on. Okay, so for every line, they took the value of the density and did the inverse, got the slope, plotted the line from the origin. Okay, now what should we do with these lines? Okay, these lines are actually wherever the line is intersecting the curve, it is the value of the flow will become the service flow rate for that level of service. Okay, for example, you see this is a line for level of service A, right? So if your free flow speed is 55, how much is the service flow rate for A? This value. If your free flow speed is 60, how much is the service flow rate for A? This value. Okay, and you can do the same thing with lines of B, C, D, and E. Okay, so wherever the lines are intersecting the curve, they are giving you the service flow rates for that level of service. Okay, and this is the main contribution of these graphs. Okay, again,
Doctor.
Yeah.
Doctor, I have a question. So each dotted line represents each level of service?
Yes.
Okay.
So you can get the service flow rates for each level of service on these highways which have free flow speed of 75, 70, and so on. Okay, these are the curves for freeways. These are the curves for multi-lane highways. Same thing, no change. Okay, the procedure is the same. The values are changing obviously, but the information given on these curves is the same. Okay, the lines showing levels of service. You have the graph, the curve for each free flow speed, and the densities are given and so on. Okay, and these are the ranges of levels of these are the ranges of density which they have used for plotting those lines. The maximum for A is 11, then more than 11 till 18 is B, more than 18 till 26 is C, and so on. Okay, and last one, as I said, at capacity it is 45. These are the service flow rates which they have taken from the graphs which are already from the curves which are already plotted. Okay, so for freeways, the curves are already plotted for 75, 70, 65, 60, and 55. So these are the values you see here. Okay, and wherever the line was intersecting, they have found the service flow rate and they have written it in this table. So you can see the lines are intersecting free flow speed curve at this point. So at this point, the flow rate is 820, the value on the x-axis. By flow rate, I mean the value on the x-axis. Okay, the value for B is 1310. Okay, so these are the service flow rates for each level of service. If your free flow speed is 75, okay, if your free flow speed is 70, then you will look at the intersection point of this curve, and so on. Okay. One thing to be noted: all these service flow rates are under base conditions. So you can see the units are passenger cars per hour per lane. The flow rate on the x-axis, passenger cars per hour per lane. The density is passenger cars per mile per lane. Okay. So again, going back to the previous assumption, all values coming or shown in these graphs or the equations are under base conditions. Okay. So we need some calculations before using these values. Okay. We will look at that. No problem. And this is for multi-lane highways. Okay. So in this case, I use the curves for freeways. Okay. And in this case, for the second case, I use the curves for multi-lane highways. Okay. Again, the units are passenger cars per hour per lane. The important point, which I will reiterate, is the table for service flow rates and the graphs, which I showed you, can only be used if the free flow speed matches exactly the one which is given. Okay, so if it is exactly 60, then you have a multi-lane highway, then you can use this table and you can use a graph for multi-lane highway. Otherwise, draw your own curve. I showed you the equation. Okay, you draw your own curve using the equation then. The tables and graphs are not for you. Okay, so if it is 61 or 59 point something, draw your own curve. Okay, use the equation. That's it. Okay, so tomorrow inshallah we'll start with, not tomorrow, on Thursday inshallah we will start with a discussion of adjustment factors, and we'll move on from there. Okay, so today we'll discuss the level of service in details and the procedure for calculating the speed at different levels of service. Okay, I showed you the equation for the speed flow graph and what do we mean by freeways and multi-lane highways. So if you have any questions, please go ahead. Critical density was the correct answer. Yes. Density which you achieve at capacity is known as critical density. Any questions, any queries, any problems, please go ahead. Everything is clear? Okay. Thank you for listening, participating, and yes, you are welcome. See you guys on Thursday. Have a nice couple of days, inshallah, and see you then. Assalamu alaikum.